Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. In my weekly sessions on ISI and CMI preparation, I have been solving previous year papers for last 3 weeks. Today I will be solving this CMI 2018 Part B. Last week I discussed 2018 Part A in which 10 questions were there. That Part A was easy. I will say not difficult, slightly towards easier. Today, let us see how these questions are. My overall assessment is that this paper was little difficult, or you can say average plus. So let us start with this first question, which says a natural number k is called stable if there exist k distinct natural numbers a1, a2, ak with each ai greater than 1 such that sum of reciprocals of all these integers is equal to 1. We have to prove that if k is stable, then k plus 1 is also stable. Using this or otherwise, find all stable numbers. So let us first check for k equal to 1. I think if k is 1, then we will be taking only one number, that is a1. So 1 upon a1 should be 1. But because of this condition that a1 has to be greater than 1, I think this is not possible. So k equal to 1 cannot be a stable number. Now coming to k equal to 2. So then we have to have two numbers 1 upon a1 and a2 so that 1 upon a1 plus 1 upon a2 is equal to 1. But because they both are distinct and they are greater than 1. So here a1, a2 both will be greater than or equal to 2. But because they are distinct, one of them has to be 3 or more. So if you take the sum of their reciprocal, it cannot become equal to 1. It could have become 1 if they both were 2, 2. So 1 by 2 plus 1 by 2 equal to 1. But if you have to satisfy this condition that they are distinct, then a2 will be at least 3. So the sum cannot be 1. In fact, if we find this a1 plus a2, the maximum sum of these two, it will be less than or equal to 1 by 2 plus 1 by 3, which is 5 by 6. So if k is equal to 2, sum of reciprocal of these two numbers with this condition will be always less than 1. So it cannot be equal to 1. So k equal to 2 is also not a stable number. Now coming to k is equal to 3. Now dear all, if you have done some questions on number system or somewhere else also, you may remember this result that 1 by 2 plus 1 by 3 plus 1 by 6. If you add, they becomes equal to 1. This clearly tells us that k is equal to 3 is a stable number. But if you do not remember this result, then also you can find what three numbers would be. Like if you are having 1 upon a1 plus 1 upon a2 plus 1 upon a3 is equal to 1, then a1, the smallest of them being 3, cannot give you this sum equal to 1. Suppose my a1 is greater than a2 and a2 is greater than a3 is the smallest one, and suppose a3 is equal to 3. In that case, you can see that 1 upon 3 becomes 1. But if a2 is greater than a3, a1 is greater than a2, then this sum will not be equal to 1. So in order this to become equal to 1, we have to have the smallest number, let us say a3, to be equal to 2, because they have to be greater than 1. So a3 has to be 2, then only there is a possibility this becomes equal to 1. And then we will have 1 upon a1 plus 1 upon a2 is equal to 1 minus half, that is 1 by 2. And now using the concept that we did in Diophantine equation by taking LCM, this will be a1 plus a2 into 2 is equal to a1 into a2. Okay, if you solve it, we will get a1 minus 2 into a2 minus 2 is equal to 4. And because a1, a2 are natural numbers, okay, and they are greater than 1, so this product becoming 4 is possible only if this larger number is a1, so this becomes 4 and this becomes 1, and that will be possible only if a1 is 6 and a2 is equal to 3, and hence this is what I was saying in the beginning. So k is equal to 3 is definitely a stable number, and we have found these 1 by 2, 1 by 3, 1 by 6 with some logic also. Okay, now the second part, which says if k is a stable number, then we have to prove that k plus 1 is also stable number. Now to do this thing, let us assume that 1 upon a1, 1 upon a2 and so on, 1 upon ak, they is equal to 1, where we have k as stable number, k as a stable number. So there have to be some a1 a2 up to ak, so that sum of their reciprocal becomes equal to 1. Now if I multiply by 1 by 2 on both sides, 1 by 2 here, 1 by 2 here, okay, what we will get? We will be getting 1 upon 2a1 plus 1 upon 2a2 and so on, plus 1 upon 2ak is equal to half. I can write like this. So we will be getting that 1 upon 2 plus 1 upon 2a1 plus 1 upon 2a2 and so on and so on, and in the end it will be 1 upon 2ak, and this is equal to 1. Now because this a1, a2, a3, ak all are distinct, and if I assume that a1 was the smallest, then a2, without loss of generality we can assume that, okay, then this a1 is greater than 1, okay, and hence this 2a1 will be greater than 2, so this 2a1 will be at least 4. So this 2 is different from 2a1, and other numbers 2a2, 2ak and so on, they all will be, you know, distinct numbers such that sum of their reciprocals becomes equal to 1. So already they were k numbers, and I have added 2 also to this thing, so my k plus 1 also becomes a stable number. So k plus 1 is also a stable number. So this completes the solution of this question. I think this first part, that k equal to 1, k equal to 2, k equal to 3, that was easier part. Even this is also easy, but this was something that if this strikes into your mind, then only you will be able to do it. Otherwise this was not that easy step. Okay, so this was average plus from, in my opinion. Now coming to the B part of this question, it says f is a differentiable function defined on a subset A of real numbers, and we define f star y is equal to maximum of yx minus fx, x belongs to A, whenever the above maximum is defined. Now for function fx is equal to minus ln x, determine the set of points for which f star is defined, and find an expression for f star y involving only y and constant. Okay, so first of all let us write this f star y equal to maximum of y into x minus plus, this will be ln of x. Okay, and here this x will be from A. In fact this ln x or minus ln x, its domain is 0 to infinity, so this set will be actually 0 comma infinity, all positive real numbers. Okay, now what we are supposed to do here, please try to understand. For any given value of y, we have to vary all values of x so that we get maximum possible value of yx plus ln y. For given y, okay, for given y, vary x in this 0 comma infinity so that for any given y, this yx plus ln x is maximum. So what we can do, we can take this yx plus ln x as some function, let us say gx, okay, where y was constant, we will be varying this x. So we will try to see when this yx plus ln x will take the maximum value. So here I have taken gx is equal to yx plus ln x. To find at which x it will take maximum value, we will differentiate it, which gives us y plus 1 by x. Please notice I have differentiated it with respect to x, taking y as a constant, because for every y we have to find that what will be the value of x for which we are going to get this expression to be maximum. Okay, now Because x belongs to 0 to infinity, hence 1 upon x will also be positive. So this will be positive throughout if my y is greater than or equal to 0. Even y is 0, then also y plus 1 upon x will be positive because x is from 0 to infinity. But if y is negative, okay, if y is negative, then it can be positive and negative both, and 0 also, I think, and 0 also. If y is negative, then I think we can have all the values. So let me first talk about this. If g dash x is positive for this scenario, then there will be no point of maxima. There will be no point of maxima. In fact, this function in this case gx is strictly increasing. And strictly increasing means as you increase the value of x, for all those cases when y is positive, this yx plus ln x will keep on increasing. We will not be able to get any maximum value of this. This will go up to infinite. And please remember, infinite is not some number whom we can claim to be a maximum. If it is maximum, then it has to be some finite value. Okay. Now, when y is negative, okay, and I put g dash x is equal to 0, we get this x equal to minus 1 upon y. In fact, you can check g double dash x in that case will be minus 1 upon x square, which is negative, which means that x is equal to minus 1 upon y is a point of maxima, This means, let me use this space. So whenever this y is negative, okay, so this yx plus ln x will be maximum when x is taken to be minus 1 upon y. And this is what my f star y would be. So I can write this f star y to be equal to, I will put x as minus 1 upon y. So y into x will be minus 1 plus ln of, in place of x I will be writing minus 1 upon y. Okay, so let me use this small space here. It will be minus 1 minus ln of minus y. Don't get confused that ln of negative number, it is not negative because y is negative. Okay, so they have asked us two things. For the function, determine the set of points for which f star is defined. So the set of point for which f star is defined is y belongs to minus infinity to 0. And the expression for f star y involving only y is this thing. Minus 1 minus ln of minus y. So this completes this question. Okay, I think this language was not that easy to comprehend. Otherwise, question was not difficult. Okay, but in the exam pressure, I will rate this as an average plus question. Okay, coming to second question, A part, where we are given that find all real solution of the equation of this thing, where x square minus 2x is in the base, x square plus x minus 6 is in the power, and this whole thing is equal to 1. Explain why your solutions are the only solution. So dear all, please understand, this will be 1 if, let me write the scenarios, x square minus 2x is 1, or x square minus 2x is equal to minus 1, and x square plus x minus 6 is equal to even integer. Then only this will be minus 1 power some even integer equal to 1. Or there is a possibility that x square plus 6 minus 6 becomes equal to 0, and my base is not equal to 0, because if base is also 0, then power 0 will not make it 1, it will make it not defined. So in this first scenario, x square minus 2x minus 1 is equal to 0. This will become x is equal to minus b plus or minus under root of b square 4 plus 4 8 upon 2. So here we get this to be 1 plus or minus root 2. And whatever this x square plus x minus 6 comes out to be, whether positive, negative, 0, doesn't matter, because if base is 1, this has to be the answer. So far we have got two solutions. Now for the second one, in this case x square minus 2x plus 1 is equal to 0, which is a perfect square of x minus 1. Hence there is only one value, that is x is equal to 1. And for x is equal to 1, we get x square plus x minus 6 to be 1 plus 1 minus 6, that is minus 4. So if power is minus 4 and base is minus 1, definitely this is going to be like minus 1 upon minus 1 power 4, and that has to be 1. So this is also a solution. So along with these two solutions, this is also a solution. Now coming to the third scenario. In this case, I think x square minus x minus 6, we get two factors. X plus 3 as one factor, x minus 2 as another factor. So we get x to be either 2 or minus 3. Okay, when this is 2, this x square minus 2x also becomes equal to 0. So in this case, 0 power 0 is the case we are getting, because power was 0 and at x is equal to 2, this base is also becoming 0. But this is not defined, it is not equal to 1. But when x is equal to minus 3, in this case, x square minus 2x will be 3 3s are 9, 9 plus 6, I think, 15. It will be 15, 9 plus 6, 15. So in the base we will be having 15, and in the power we will be having 0. So definitely it will be 1. So the complete answer, so the solution set, if I write, that will be 1 plus root 2, one solution, 1 minus root 2, second solution, 1 another solution, and then minus 3, the fourth solution. So there are total 4 number of solutions, and I have explained why these are the only 4 solutions. Other than that, we cannot have this to be equal to 1. Let me just repeat. We can get this to be 1 if my power is 0, base is non-zero, 1. Or base is 1, then power can be anything. Or base is minus 1 and power is an even number. Then only it can comes out to be 1. So using all these 3 scenarios, these are the 4 possible answers. Okay, so I think this was easier question. I think we have seen such questions once in JEE mains also. Okay, now coming to B part. Following expression is a rational number, find its value. Okay, dear all, I have 2-3 methods for this question. I'll tell you one by one. So my first method is that if I take this to be equal to, let us say, x. Okay, then what we can write this to be cube root of this thing plus negative of cube root of this thing using this bracket plus minus x, this will be equal to 0. I have not written, but inside this is 6 root 3 plus 10, or let me write it, 6 root 3 plus 10 here and 6 root 3 minus 10 here. Now, you know this identity, if a plus b plus c is 0 and a is not equal to b, and a, b, c all are distinct, and a, b, c are distinct, or I should say a, b, c are not all equal, then you know a cube plus b cube plus c cube becomes equal to 3abc. So I am going to use this thing here, and because these two numbers, one this, second this, they are distinct, so definitely their cube, that is 6 root 3 plus 10 minus, or let me write plus then minus inside the bracket, 6 root 3 minus 10 here and minus x cube. So this is a cube, this is b cube plus c cube, and this is equal to 3 times inside cube root. Okay, and there is two minus sign, they will become positive, and inside cube root sign you can check, it will be 6 square, that is 36 into 3, 108 minus 100, so we will get this to be 8. And here this 6 root 3 are getting cancelled, so we are getting 20 minus x cube is equal to, on the right hand side we are getting 3 into 2, that is 6. So x cube, yes, sorry, there is one more thing I have missed, I think here, that is x here. So on the right hand side, it will be x. So this becomes x cube plus 6x minus 20 equal to 0. And you can check putting x is equal to 2 is satisfying it. So x minus 2 will be one factor. The other factor will be x square and plus 2x plus 10. You can check these are the factors, and this is having non-real roots. Non-real roots. So that means only possible solution will come from this factor. So this x will be equal to 2. So following expression is a rational number, then this value is 2. 2 is the answer. Okay. Now if we have to do this question in another way, please see how we can do it. Let us call this as A and this as B. Okay. So we have got x is equal to A minus B. If I do the cubing both sides, so x cube will be A cube minus B cube minus 3AB into A minus B. Okay. Now putting these values, we will get A cube minus B cube. If I cube them and subtract them, I think we will be getting 20, because 6 root 3 will be cancelled. 10 minus 10 will be 20. And minus 3 into AB, that is product of these two. I think this comes out to be cube root of I think 8 here. And A minus B, I can write this as x. So you can check we are getting exactly same cubic here, the x cube, and this will be 6x minus 20 equal to 0. So same thing after this step. This is also, I think, very easy method, but this was something that I always suggest students to think on this line, because many times this A cube plus B cube plus C cube is equal to 3ABC is useful. Okay. Now coming to question number 3, which says let f be a function on non-negative integers defined as follows: f of 2n is equal to f of fn and f of 2n plus 1 is equal to f of 2n plus 1. If f0 is equal to 0, we have to find fn for every n. So let us do this A part first, because f0 is 0. Okay, so using this second definition where f of 2n plus 1 is f of 2n plus 1, putting n is equal to 0 here, we will get f1 to be equal to f0 plus 1, hence this will be equal to 1 here. Now then f2, if we need to find, we can write using first definition n as 1, so f of f1 is 1, so we can write this as 1 here, and once again f1 is 1, so we get f2b to be equal to 1. Now similar to this, if we find f3, this will be f2 plus 1, so that will be 1 plus 1, that is 2. Okay. Now dear all, please understand what we have proved, that f1 is 1, f2 is 1, and then f3 is 2. Now if I find f4, okay, then using my first definition, this half of 4 will be that number that has already occurred, like 1 out of 1 2 3, it will be a number from these first 3 only. In fact, it will be f of f2 here, and at 2 f2 is giving us 1, so this will be f of 1, and because f of 1 is 1, so this value will also be 1 here, and from this we will be getting f5 to be equal to 1 plus 1 is equal to 2. Okay, now if I do it for next even number 6, half of this even number will be from those numbers which have already appeared before, and you can see the values which we are getting as of now, they are either 1 or 2. 0 was only for 0, but half of any even number will not be 0. It will be either some 1 or 2 or 3 like this. So if I take this f of 6, we can write this f of f3 here, and f of 3, it is 2, and at 2 the value is 1. So in 2 steps, if we write, it will be 1 only, and this will give us f7 to be equal to once again 2. Now if we do for f8, what I am trying to tell you, that till 7 we have seen the values were either 2 or 1. Okay, now if I do it for 8 and I use my first definition, this, if I take 2n is 8, my n will be 4, okay, and this n that is 4 is definitely such that this f of 4 is the value which has already appeared from this f1 till f7, which are either 1 or 2. So here this will be either 1 or 2. In fact, for f4 it is 1, and for 1 we have got the value to be 1. So what I have said so far, that for every even integer we are going to get this to be 1, and for next number that is odd, it is going to be 2. So for every even number it will be 1, next number it will be 2, then next even number whose half will be from those numbers only which has already appeared. Okay, so what I'm saying, that if you go for some higher even number, let us say f of 2m, we can write this as f of fm. Okay, now this fm is something that has already appeared before 2m. I am assuming that till 2m minus 1 I have proved that this is equal to 2 here. Okay, so till 2m minus 1 the values before that were either 1 or 2. So here this fm will be taking either value to be 1 or it will be taking the value to be 2, and f1 and f2 both are 1 1, hence this even, for any even number f of 2m will always be 1, and next odd number it will always be 2. So we can conclude that my fn, okay, which was 0 for n is equal to 0, okay, then it was 1 for n is equal to 1, but later on we found that this is also 1 when n is even number except n is equal to 0, and it is 2 for all n odd number except for n is equal to 1. So this is how this function will be behaving for this a part. Okay, now coming to the b part, which says show that f0 cannot be equal to 1. Let us see what is the problem with this f0 becoming equal to 1. Let us assume this is equal to 1. Then if I use this first definition, my f0 will be equal to f of f0. I have taken n to be equal to 0. Okay, and because f0 is 1, I can write this to be equal to f of 1. Now dear all, we can use the second definition to find f1, which will be 1 plus 1, that is 2. Okay, and here if I put f1 is equal to 2, what we are getting here is that f0 is coming out to be 2, but we were given f0 to be 1, which is a contradiction. See, this is a function, so at same number 0 we cannot have two different values. So we can directly conclude now that f0 is not equal to 1, and hence proved. So this b part I think seems to be easier. Okay, now coming to the c part, in which we are given, we are asked that for what non-negative integer k, if any, can f0 become equal to 2 power k. Dear all, please see, for non-negative integer k, so if I take k equal to 0, because 0 comes under non-negative integer, this 2 power k will become 1, and in the b part we proved that f0 cannot be equal to 1. So maybe there is a possibility that f0 will not be equal to 2 power k for any value of k. Let us see. So here what we have, we are given that f0 is equal to 2 power k, that I am assuming here for this c part. And I can write this also as f of f0 by taking n is equal to 0. Okay, and because f0 is 2 power k, so we can write this as f of 2k. Okay, so what we have proved, that f of 2k is equal to 2k. Okay, now if I find the value of f1 here, using this f0 is equal to 2 power k, it will be just 2 power k plus 1. Okay, from this, one more thing that we can conclude is f of 2k plus 1, using this one, I can write this to be 2 power k plus 1. Okay, so this is what we have proved. Now, if you try to find this f of 2 power k once again, using my first definition here, it can be written as f of f 2 power k minus 1. Okay, or if I do it one more time, f of f it will be 2 power k minus 2. Or if I keep on doing it, I think k times, so f of k times, I think in the end it will become f of 1. Okay, now what is f1? We have proved that f1 is equal to 2k plus 1. F of f and so on. F we'll be getting f1 as 2k plus 1. Now because f of 2k plus 1 is 2k plus 1, so every time we will be getting 2k plus 1. So if we keep on doing it, in the end we will be getting f of 2k plus 1, and this will be equal to 2k plus 1 only using this definition. But as you know, we proved this f of 2k is equal to 2k also, with the assumption that f0 is equal to 2 power k, but we are getting f of 2 power k equal to 2 power k plus 1 also. So I think there is a contradiction. So this f0 equal to 2 power k not possible for any k belongs to whole number, non-negative integers. So for any whole number it is not possible. In fact, this is very much similar to B part only, where where we proved that if we got f0 to be 1, we got f0 to be 2 also. If we got f0 to be 1, we got f0 to be 2 also. And here also it is similar to that only, that we got f2 power k equal to 2 power k, then we got this to be 2 power k plus 1 also, but this is not possible for f to be a function. So this is how we proved that this is not possible. I think this part was not that easy, especially in exam pressure. B part, I will say it can be done, and A also you can, you can write many numbers and after that you will see the pattern. So this A and B parts are easy. C part was not that easy, so I will rate this question to be difficult in totality, considering C part also. Okay, now coming to the fourth question, which says ABC is an equilateral triangle with side length 2. Okay, so AB is 2. A dash is chosen on the side BC such that length A dash B is K. Okay, so this is K and this is less than 1. That is why this A dash is lying on the lower half part of this BC. Likewise, B dash and C dash are chosen on the side CA and on CA and AB such that CB dash is K. So this is K and AC dash is also K. So these remaining sides will be 2 minus K here, 2 minus K here, and 2 minus K here. Line segments are drawn from point A dash, B dash, C dash to their corresponding opposite vertices. So A dash to A, B dash to B, and C dash to C. The intersection of these line segments form a triangle labeled PQR. We have to prove that PQR is an equilateral triangle with side length of this. I think this can be said by symmetry also, but let us try to do it in proper manner. Okay, so first of all, what we can see here is this angle is 60 because it is equilateral triangle. Similar to this, this angle is also 60 degree, and there is one more triangle, that is this one. This is also 60 degree. Okay, now if you consider this triangle A dash B, A dash B, and then triangle B dash C, and triangle C dash A. Let me check. C dash A. I think they all are congruent to each other. Why I am saying congruent to each other? Because they have two sides, K and 2, K and 2, and K and 2, and angle included between them to be 60. So from side angle, side criteria, they are congruent. Okay, and if they are congruent, that means this angle here, I am putting a single dot here, will be equal to this single dot here, and this will be equal to this single dot here. Okay, and I'll put this double dot here. I'll put this double dot here, and there is one more triangle. I think this double dot here. Okay, now what we can conclude here, let us see. In these triangles, if you see like in this triangle AA dash B, AA dash B, I'm talking about this angle A I called as dot, single dot, angle A dash I called as double dash, and angle B is 60. Angle B is 60. Now with this logic, in this triangle APC dash, APC dash, because already we have these two angles to be dash and double dash. Angle A is same, dash only. Okay, angle C dash is double dash here. Okay, so this remaining angle at P, has to be 60 here, because from angle sum property, sum of these two is such that third angle is 60. So here also the third angle will be 60 here. So this angle has to be 60 degree. Okay, so similar to this, we can conclude that for R also and for Q also, this angle is going to be 60, 60, 60. So this angle in the triangle PQR, I can say PQR, all angles, angle PQR, they are 60, 60, and hence this is equilateral triangle. Now coming to the other part, that is the side length of equilateral triangle will be this thing. To do this, let me take one more slide for this. Okay, now to do this thing, let us do some similarity here. Let us try to find some similarity here. First, before that, I will be calling these lengths AP as A and A dash Q as B, and this length I will be calling as T, and we are supposed to find this T only. Okay, and if it is A, I think CR will also be A. We have proved these triangles to be congruent. So this here will be B, this here will be B, and this here will be A. This will be T here, this will be T here. Okay, now as this angle is 60 degree, okay, using cosine rule, and this is K here, I can write cos 60 to be equal to 2 square, that is 4. I am taking this AB length as 2. This is given in the question actually. So 4 plus K square, 4 plus K square minus AA dash, which is sum of A, B and T. Okay, upon 2 into K, and cos 60 is 1 by 2. So simplifying it, we will be getting AA dash square to be equal to, I think if I bring this side, it will be 2K here. So this will be K square plus 4 minus 2K. Maybe it is the beginning of the solution of this, because here also we are getting similar kind of expression in the denominator. Now let us see how we can make use of this thing. So AA dash square is this. Now maybe we can find the value of A, B in terms of K, and that will help us to solve it. Now everybody please see, this angle I wrote as single dot there, okay, and this angle I took as double dot here, and this also we got as the double dot. Okay, so if you check, we are having two triangles. I'm writing one as APC dash. You can notice APC dash. Okay, and there is one more triangle which is A. At P it is 60 degree. If you remember, this angle was 60. So at P if it is 60, and I'll be taking A, then B, and then A dash. So you can check, these two triangles are such, they have all the three angles to be equal. At A here single dot, at A in this bigger triangle also single dot. At P here we are having 60. In this other triangle at B we are having 60. At C dash we are having double dot angle, and at A dash also I am having double dot angle. Now if we compare the corresponding sides of these two similar triangles, so in front of this single dot I am having B here in smaller triangle, whereas in the bigger triangle in front of this single dot we are having A dash B, which is K. Then double dot angle. In this smaller angle it is A here, and in this bigger triangle it is 2 here. In front of double dot, this side length is 2, and then in front of this 60 degree we are having a C dash, which is K here. 60 degree in smaller triangle. In this smaller triangle APC dash, this is K here, and upon it will be AA dash here. AA dash here. Okay, so what we have got from this, what we are trying to find out, we are trying to find A and B in terms of K, so that we can find T in terms of K. That is the ultimate goal here. So we are getting B to be K square upon AA dash, and we are getting A equal to 2K upon AA dash. Okay, now if I use this AA dash from here, which is actually A plus B plus T, okay, and let me use these values of A and B here. So we will be getting K square plus 2K upon AA dash plus T. Okay, from this the value of T would be, this will go that side, I think we will be getting AA dash square minus K square plus 2K after taking this AA dash to be LCM. It can be verified, this will be going that side. So AA dash square minus this thing, yes, and AA dash square is this. So if I put this value here, K square minus 2K, so K square will be cancelled, and we will be having 4 minus 4K, I think 4 minus 4K in the numerator, and AA dash is under root of K square plus 4 minus 2K. AA dash is this thing, and that is what we are looking for. I think this completes the solution of this question. See, this question in which only equilateral triangle is to be proved was not that difficult, but this other part was little tricky. Okay, I tried to solve this in another method also, where I plotted one line like this, which is parallel to this AA dash. So using that BPT, basic proportionality theorem also, we can find A and B in this manner, but I think this one is the best method. The way I have done here I have not found easier than that. Okay. Coming to this question number 5, which says an Alien script has n letters B1, B2 up to Bn. For some k less than n by 2, assume that all words formed by any of the k letters are meaningful, written left to right. These words are called k words. Such a k word is considered sacred if, number 1, no letter appears twice, and if a letter Bi appears in the word, then letters Bi minus 1 and Bi plus 1 do not appear. Okay, so if one letter is there, neither its previous nor next one should appear. It is not saying both do not appear. It is saying letter this and this do not appear. So if suppose B2 is there, we will not consider B3 nor to B1. Okay, and here they have called Bn plus 1 as B1. This is given because for B1 my next number will be B2, or next letter will be B2, and before this will be B0, and B0 we will be taking as Bn. So for B1 it is also having kind of two neighbors, one is B2, one is Bn. Similarly, Bn plus 1 is B1. This will be useful for number Bn, whose neighbor before it will be Bn minus 1. Its next neighbor would be Bn plus 1, and Bn plus 1 is actually B1 here. Actually, what we can do, we can assume these letters to be written on a circle like this: B1, B2, B3, and so on, Bn, Bn minus 1. Okay, so here for every number B1, we are having exactly two neighbors. Okay, so with B1 we are supposed not to take Bn or B2. For B2 we are not supposed to take B1 or B3. So actually what we have to do, actually we have to select k letters first, which will be such that no letters appear twice, so they all are distinct, and number 2, no two of them are consecutive. That's it. And once we have done that selection, we will be making a k letter word. That will be done, I think, in just k factorial after making that selection. Now how this selection is made, that is important. So to make non-consecutive selection, I'll be telling you something. Okay, let us assume we have n natural numbers, 1 2 3 4 and so on, n natural numbers, and we have to select k natural numbers from them so that no two are consecutive. So that no two are consecutive. So here what I'm telling you that that I have n natural numbers and I have to select k natural numbers so that no two are consecutive. And here I am not assuming 1 and n are to be consecutive as given in this question. I am telling you some different theory, then I will come to our original question. Okay, so we just trying to explore how to do this question. 1 and n are not consecutive, please understand that. To do this question, what I suggest, take k red chairs, all identical, n minus k white chairs, all identical, arrange them so that no two red chairs are consecutive. Okay, arrange them so that no two red chairs are consecutive. Place 1 2 3 and so on n from left to right in the same order on them, and then take those numbers that lie on red chairs. I think you are able to get the analogy what I'm trying to say. Okay, so if we are doing this question in this manner, our question just reduces to how to arrange k red chairs and n minus k white chairs so that no two red chairs are consecutive. So to do this thing, so I think in PNC we have one very standard method. Whatever objects are to be such that no two of them are consecutive, we put them later. We first place white chairs, n minus k white chairs, and because they all are identical, this will be done in just one way. And then we will find k gaps between white chairs. And how many gaps will be there? Because n minus k white chairs are there, so in between and sideways, one on the left, one on the right, we will be having n minus k plus 1 gaps. Okay, so find k gaps between white chairs. It will be n minus k plus 1 gaps in how many ways? N minus k plus 1 ck. And then arrange red chairs in those selected gaps, which will be again in one way only. So what you can see that doing this thing will be done in just n minus k plus 1 ck ways, and that is the answer for this question, n minus k plus 1 ck ways. Now why I told you this thing? In our question we are supposed to do this thing on a circle, and if we have to do it on the circle, then also if we know this thing which I told you, it will be very easy to do. Please see how. Now I am on to this question where we are supposed to choose k letters so that no two are repeated, no two are identical, and no two are consecutive. So what I'm going to do, that select first letter, and this will be done in how many ways? I think n ways, because my first letter can be any one from these n, because later on there will be some constraint, but in first letter there is no constraint, so I can select in n ways. Now let us assume this is B2. It could have been anyone, so let us say it is B2. So if B2 is selected, and because of this condition B1 will not be selected and B3 will not be selected. Okay, now we have to select remaining k minus 1 letters from which letters? I think B4, B5 and so on, Bn minus 1, Bn. You can check, they are n minus 3. They are total n minus 3. And also after this B2 is selected, and because of that B1 and B3 are not selected, this B4 and Bn are not consecutive. You can consider them into a circle, but this sense of circle is gone. We can better take them to be lying on a row. And then it is exactly same thing which I told you here, that among n we have to select k natural numbers so that no two of them are consecutive. If I apply this theory here, so out of these n minus 3, I have to select k minus 1 letters which are non-consecutive. So this is actually like n k minus 1 red chairs, and n minus 3 minus k minus 1 white chairs. That is equal to n minus k minus 2 white chairs. Okay, so if you select these letters from these n minus 1 letters so that no two are consecutive, this will be done in how many ways? First, I will be arranging all white chairs in just one way. Then we will be finding gaps, and these gaps will be n minus k minus 2 plus 1, so minus 1 here. And see how many gaps we have to find? I think k minus 1. So this is the number in which we will be finding remaining k minus 1 letters. Okay, I think I have to take one more slide for this. Okay, so what I have done, that we selected first letter, let us say B2, which I took in that example, okay, in n ways, and then I selected remaining k minus 1 letters in n minus k minus 1 c k minus 1 ways. Okay, dear all, in this one there is one catch, try to understand. Suppose we chose B2, B5, B, let us say 8, Bn minus 1. Okay, these 4 letters we chose, and assume that k was 4 only. Okay, so in the beginning I said, we can choose any number from these n in the n ways. Okay, suppose you chose B2, but there are chances in these n that we could have chosen B5 also, B8 also, or Bn minus 1 also. And later on we chose remaining the same 3 letters, like with B2, if we chose B5, B8, Bn minus 1 later, we could have done this question that we started with B5 and later on we chose B8, Bn minus 1 and B2. Then also we will be having same selection. So you can see that there are k ways in which we will be actually getting same selection. So in this case we will be dividing it by k. Okay, I'm just refreshing what I've done. First I selected first letter, which could be anyone from these n letters in n ways. Then from remaining n minus 3, because once one of the letter is selected, 2 neighbors are rejected and we are left with only n minus 3 choices. from which we have to choose k minus 1 letters so that no two are consecutive. So as I told you this theory in this slide, it will be done in n minus k minus 1, c k minus 1. In this one, there is a catch that you can make same selection with starting with B2 also, or B5 also, B8 also, and Bn minus 1 also, where k is equal to 4. Okay, so if it is actually k, then we can have same selection in k different scenarios. So this will be actually repeated k times. So this is the number of selection of number of selection of k letters with these two conditions. Okay, so number of words. So number of words would be, we just have to multiply it by k factorial, n minus k minus 1 c k minus 1 into k factorial, because these k letters, if they are different, arranging them will be done in k factorial. So if we can simplify it, I think it will be n into k minus 1 factorial into n minus k minus 1 ck minus 1. So that is the formula for all n and k. Now they have said that if we take n to be 10, k to be 4, so this will be 3 factorial into, so 10 minus 4, 6 minus 1, 5, C3. So this will become 10 into 10, 100 into 6. So answer will be 600 for this question. Okay. Dear all, let me tell you, for this thing, and for this thing, that non-consecutive selection which I have told you, there is another way also for doing the same thing. Let me tell you in another slide. I'll just give you the hint. You may try it on your own later. Let me remove this also. Yeah. Now suppose, let us assume that B1, B2, B3 and so on, Bn, they are n letters, and let us assume B1 and Bn are not consecutive. Let us assume this is the scenario. Then as I told you, selecting k letters will be done in how many ways? I think n minus k plus 1 ck. I think this is what I told you here, n minus k plus 1 ck ways. This is when we are assuming that B1, Bn are not neighbors. Now from this we have to subtract those cases in which B1 and Bn both are selected, because if they both are selected, in our question this is not permitted, but in this ways we have chosen those ways also in which B1 and Bn both are selected. Okay, so if we select B1 also, Bn also, so obviously we will not be considering B2, we will not be considering Bn minus 1, so we will start considering from B3, B4 and so on, and Bn minus 2. Okay, and here 4 numbers are discarded, so we will be making a k minus 1 selection from n minus 4 such letters with the same condition that no two are consecutive. We are just subtracting those cases in which B1 and Bn are both selected and no two are consecutive. Okay, so no two are consecutive, that means we will be having n minus k minus 3 white chair, I think, and number of gaps would be n minus k minus 2, and number of red chairs would be k minus 1. So these are those cases in which B1 and Bn both are selected. So if you subtract from this to this, also you will be getting same thing which I have written as n by k into n minus k minus 1 ck minus 1. You can check, this will be exactly same thing. Okay, but still I feel this method is better, selecting one of them in n ways, then selecting k minus 1 non-consecutive letters and then dividing by k. Okay, so this completes this question. Dear all, these things I always tell my students, and this is one very standard thing also. You may find it in many different books also. But if you're not aware of these ideas, then I think this question was not easy at all. This is my opinion. I will call this as an average plus, or you can call this as difficult question also. Now coming to the last question. We are given that imagine that unit square in the plane to be carom board. Assume that striker is just a point moving with no friction so that it goes forever, and that when it hits an edge, okay, the angle of reflection is equal to the angle of incidence as in real life. Okay, if the striker ever hits a corner, okay, whenever it hits a corner like this, it will fall into the pocket and disappears. Okay, the trajectory of striker is completely determined by its starting point x comma y, okay, and its initial velocity p comma q. Okay, if the striker eventually returns to its initial state, that is initial position and initial velocity, that means it is not just you have to come back, you should be come back so that your velocity at that point is same as it was in the beginning. Initial position and initial velocity, we define its bounce number to be number of edges it hits before returning to its initial state for the first time. Okay, for example, the trajectory with initial state 0.5 comma 0.5, I think they are saying the dimension is 1. Okay, so we are assuming this to be 0 comma 0, this is 1 comma 0, this is 1 comma 1, and this is 0 comma 1. So this point in between it will be 0.5 comma 0.5, and 1 comma 0 velocity means 1 in x direction, 0 in the y direction, so it will be going like this. And because it will be hitting it normally, so it will be coming back this way only, coming back this way only. So while coming back, it will be reaching the same point, but this at this point it will be having same position but not same velocity, because in the beginning its velocity was going like this. So it has to be go there, and once again with one more reflection it will be coming back, and then it will be having same initial state. So it is actually having two bounds, one at this point and one at this point. So if it is starting from 0.5, 0.5 with velocity 1 comma 0, it will require two bounds, or bounce number will be 2, and it will return to its initial state for the first time in 2 time units. And the trajectory with initial state 0.25 comma 0.75. So x coordinate is 1 by 4, y coordinate is 3 by 4, and 1 comma 1 means x direction velocity, y direction velocity is 1 comma 1. So it will be going like this. It will be exactly 45 angle with x direction or y direction. So it should meet at the midpoint of this side. And after reflection it will be going like this. Again it will be 45 degree with x-axis, and then again it will be going to the midpoint. From geometry it can be proved. Once again this angle will be 45, it will be meeting the midpoint, then it will be meeting the midpoint, and then it will be going through the same trajectory. So it will be reaching this point, and it will also be taking the same velocity at this point. That means to reach this initial state, 1, 2, 3, 4, these are the 4 times it will be hitting these edges. So bounce number here is 4. Very tricky, very complicated type questions. I think you will have to spend at least 2, 3 or maybe 4, 5 minutes to understand this question first. Okay, now what is the question? Let us see. The question says, suppose the striker has initial state 0.5, 0.5, p comma q, p greater than q, greater than or equal to 0, then what is the velocity after it hits an edge for the first time? Okay, so let me make the diagram. 0.5, 0.5 means it will be just midpoint. Okay, and this is the direction in which x velocity, y velocity will be same. If it goes into this direction, they will be same. But if they are saying p is greater than q, that means its x velocity will be more than y velocity. So it will be going like this, so that its x velocity is more, y velocity is less. If that is a scenario, after reflection it will be going like this. Okay, in this it can be checked. its x velocity will be same because it is reflected from this vertical wall. Okay, so whatever x velocity is here, uh, sorry, I just said opposite, its x velocity will become negative, but y velocity will remain same. Y velocity is, taken along y direction, component along y direction. So if this is the direction with p comma q, its x velocity will be p here after reflection, because it is getting reflected from a vertical wall. So x velocity will be reflected, it will be just minus of its previous value, but y value will remain same. So if the first case in this A part, I think if p greater than q greater than or equal to 0, in this case, after hitting, its velocity will be, I think, minus p comma q. And they are using this notation, so let me use this notation here also. Now if q is greater than p, I think in this case, this was when p is equal to q. If q is greater than p, that is y velocity is more, so it will be going like this, and after hitting it, it will be going like this. So here, because it is getting reflected from this horizontal wall, in this case its y velocity will be changing its sign, x velocity will not change. So here answer will be p comma minus q. Okay, I hope it is clear that because it is going on a frictionless path and following that reflection law, so these two angles will be same. So after hitting at this point, x velocity will remain same. Okay, x component will remain same, but y component will become opposite, so minus q here. So for A part, these are the two answers. Now coming to B part, draw a trajectory with bounce number 5 or justify why it is impossible. Maybe this is one hint that it may be impossible. Please understand, if bounce number is 5, okay, so bounce number 5 means, suppose these two walls are horizontal. Sorry, these two walls are vertical, and these two are horizontal. So what you can see here, if we want this number to come to its previous state, okay, so if it is getting reflected from once from this vertical wall, its x velocity will be changing its sign. So getting same x velocity, it has to get hit once again from this vertical wall. So in order to get its initial state, number of hit from vertical wall or from horizontal wall has to be even. Then only it can reach to its initial state. Okay, so if from vertical wall there are n number of hits, and from h number of walls there are m number of hits, in order to reach this striker to its initial state, they both should be even. And if they both are even, then the bounce number has to be n plus m, that is equal to even. So having bounce number 5 is just not possible. Okay, why I said even? Please understand, just to preserve x velocity. I think whenever this striker is hit by this vertical wall, its x component of velocity will take negative sign. Now to make it once again to the other side, I think there is required to be one more hit from the other vertical wall. Then only it will have same x component which it was having in the beginning. So if we want same x component, and we want this to be, because this initial state means it should be having initial velocity also, and initial velocity means both x and y component of velocity should be same. So in order to have same x component, I think we need to have even number of hits from vertical walls, and similarly to have same vertical component of velocity, we need to have even number of hits from horizontal walls. So number of bounce number has to be even, it cannot be 5. So I think this B part is just not possible. Now coming to C part, let me take another slide to do this part. C part says consider the trajectory with initial state x comma y, any general point, and p comma 0. So it is going only in the x direction where p is positive integer. In how much time will the striker first return to its initial state? Okay. So suppose this is the point x comma y, and because it is going only in the x direction, so this is the first time it will be getting hit by this vertical wall. So it will now be going back and going back here, and once again it will be taking, let me use different lines but representing superimposed line only, just to show that first, right, let us say from A point it is going to B, then from B it is going to A, and then from A, let us not use like this, let me write this. Okay, and after taking one more bounce from there, or one more hit from this vertical wall, it will be going back like this. So A to B, B to A, then C, and then C to A. Okay, so if it is x comma y, okay, then A to B, AB will be actually 1 minus x. If this is x till this point and total length is 1, so AB will be 1 minus x, and AC will be x. Okay, and because it is on a frictionless path, okay, it is on a frictionless path, and when it hits an edge, the angle of reflection is equal to the angle of incidence as in real life. Okay, and we are assuming here that it will be having same velocity while coming back from this B point. Okay, so the total path it is traveling is actually A to B, that is 1 minus x. It is 2 times A to B, then B to A, then A to C, and C to A. So the total path travel will be actually 2 units. And every time its velocity, or I should say speed along x direction, is p. So time taken to reach back to this point A with same initial velocity will be 2 upon p, distance upon speed. So that will be the time in, I think, seconds, or let me say, I think I'll say unit. Okay, so that will be the answer for this part C. Now coming to the D part, which says what is the bounce number for initial state x comma y and p comma q, where p and q are relatively prime positive integers, assuming the striker never hits a corner. Okay, it never hits a corner. Okay. Let us do this question in this way, that this point x comma y, whatever velocity it is having, p comma q, let us resolve it into 2 parts. One is x direction, one is y direction. Okay, we can think of that at this point we are having 2 different particles, different strikers. One is going with speed p comma 0, and one is going with the speed 0 comma q. One particle going with p comma 0, one going with the speed 0 comma q. Okay, so as we did in the C part, the striker which is going with this speed p comma 0, it will be at its initial state after time 2 upon p, and this will be done after 2 bounce, in 2 hits, I will say, not bounce, okay, in 2 hits from vertical balls. This is for that particle. Okay, and similar to this, the other particle which is going in the vertical direction, it will be reaching to its initial point after 2 upon q unit time, and that will also be in 2 hits from these x in these 2 horizontal walls. Okay, now I have assumed, for the sake of solving this question, that this particle is actually 2 particles, but it is actually 1. Okay, or if you consider these to be two different particles, we have to wait when both the particles will be reaching this same point at the same point of time. Then only we can say that one striker with velocity p comma q return back to this same point with same velocity. Okay, there are chances 2 upon p and 2 upon q are different. So the particle which is going into the horizontal direction will be reaching at this point at some point, and this particle going into the vertical direction will be reaching 2 upon q, will be reaching the same point in at 2 upon q unit time, but they may be different point. So if they are different point, I think the same striker, if it would have been with the speed p comma q, it will not be reaching at this point at either 2 upon p time or 2 upon q time. It can be like at 2 upon p time, this striker will be having same x coordinate with same x velocity but different y coordinate or different y velocity. Or at 2 upon q time, it will be having same y coordinate as in the beginning with same y velocity but not x coordinate or x velocity as in the beginning. If we want both x coordinates and x y velocities, x coordinate y coordinate and x velocities y velocities to be same at same point of time, we have to make sure that after t rounds, you can say this, and after let us say s round, they both become same time. 2 upon p becomes equal to 2 upon p into t after making t rounds, and 2 upon q into s after making s rounds. These two times are same so that both particle will be at the same place. Okay, and if they both are same, what can be the least possible values of t and s? Least values of t and s would be, I think, p and q respectively. Why I'm saying so? Because p and q are relatively prime, so there cannot be any other number less than p and q which can divide p and q so that they both will become equal. So here this t and s both will be taking values as p and q. Okay, so after 2 seconds actually, so they both will become equal to 2. So after 2 seconds, they will be, this particle or the striker will be at the same position, and for that it will be hitting 2p times horizontal wall, 2p times, sorry, vertical wall, and 2q times horizontal walls, because this t was p, s was q, and in 2 upon p times it is hitting vertical wall 2 times. So in this p such motions, it will be hitting vertical wall 2p times and similarly horizontal wall 2q times. So in this case, the bounce number, this bounce number would be actually 2p plus 2q. So I think that is the answer for this particular question. This was definitely very good question. Actually, this question belongs to physics, I will say. So if I now look at these questions, so I will say this question to be difficult overall. This question was also not easy. I will say this is also difficult. Now this second part was difficult. First was not that easy. So average plus, you can say. This was mixed of easy, average and difficult. So let us call this also average plus. Before that, I think this second one, both part are easy. And first part, I think this was average, and next one was average or average plus, I can say. So this is how these questions were distributed. And this completes the solutioning part of this paper. I hope you will like these solutions. Okay, write comments if you think you want to make any one of them. I will take them as a feedback, and I will like to, I will like to use that feedback in other sessions, or maybe I'll answer you in their comment itself. So that is all for today. Thank you so much, everybody. Bye bye. Take care.